a data scientist, a data analyst, just a regular statistics student, manipulating data and cleaning data is going to be a vital part of your job or your school. It's going to be super important. So today we're going to be getting into the Tidyverse package, specifically the Dplyr package, and show how important it is and give you a little bit of tips and tricks behind it so that if you've never used it before, you can kind of have a beginner understanding because it's going to be super important if you're working in R in the future. So the first thing you're going to want to do is install packages. That's this line right here. I've already done that and I've already loaded in the library, which is the next line. So if you haven't done that already, go ahead and install the packages and then load in the library, and then you'll be all set. For this specific example, I'm going to be using the mSleep data set. So that's right here. You can see that we have a bunch of different mammals, their genus, whether they're a carnivore, omnivore, herbivore, their order, and a whole bunch of other stuff. And basically what we're looking at here is sleep for these different mammals. We can also see that we have brain weight and body weight. So we're going to be manipulating this data set. All right, so the first concept I want to get into is called piping, and that comes in with the Tidyverse data set, or excuse me, the Tidyverse package. So if you're using base R, you might use a command like this to see the top 10 rows of the data set. So if we run that, we can see that we get the top 10 rows of the data set. That's just what you would do in base R. But if you wanted to use piping syntax, which is what we'll be using for the rest of this tutorial, we would type in the name of the data set, so mSleep, and then the piping operator, which here, that's what that piping operator is. And what this is doing is saying this data set, mSleep, is going to be sent to the next function, and it's going to be an input argument for it. So that next function, we can still use head, but this time we don't type in the data set and we just type in 10 instead, which is that second input argument. So this signifies that we're going to be looking at the top 10. So if I were to comment the original out and run this on the piping operator, we can see we get the same exact thing. We get the top 10 rows of that data set. So just keep that in mind as we move forward. That's what that piping operator looks like, and that's what it means. So all it's going to do is just send that data set or whatever it is into the next function as an input argument. All right, so the first real concept we're going to be getting into is select. Now what select does is it filters the data set based on columns. So again, we're going to be using that piping operator, and we'll put that in. And we'll look at the data set and see what I mean. So we have all these different columns in the data set. We have name, genus, vor, like I said before. And let's say we want to select a few of them. So let's say we want the name of the mammal. We want whether they're a carnivore, an omnivore, or an herbivore. And we want their total sleep time. So what I would do is I'd mSleep and the piping operator. We can go to the next line and you can see that it's indented, indicating that you are still within that piping operator. And then we'll type select. So let's select the function within the Tidyverse package, and we will put the names of the columns that we want. So we want name, and you can see it pops up in purple there, indicating that it is a column in the data set. So comma, and we want vor, and then we want sleep total. So we'll type that in, it'll pop up, we can click on it there. And when we run this, it's going to select those specific columns. So now you can see up here it tells you the shape of the data set. We still have 83 rows just like before. We can see that up here. But now we only have 3 columns. We have name, vor, sleep total. So another way to use select is, say we want to get rid of a column. So we type in the data set, chaining operator, and select. Now say we want to get rid of the order column. We don't want it. It's not necessary. It's taking up space. So we could type a subtraction symbol and then order. So let's run that. So now you can see we have 83 rows still, but we have 10 columns. And you can see in the original over here that there was 11 columns. And we got rid of the order column, which was either right here or right here. So now that's another way you can use select, is to get rid of columns. So what you're saying here is you're selecting every column except order. All right, so that's the basics of select, and we can move on to the next thing, which is another important one. So this one is mutate. You're going to be using this one a lot, and what mutate does is it preserves the formatting of all the other variables and all the other columns in the data set, but it's going to make a new variable based on some conditions. So I have a couple examples here. First, we're going to be doing a numerical computation, and we'll look at a proportion. So let's go back to the data set and look at that. Say we want to know the proportion of an animal's brain weight to their body weight to see who has the heaviest brain compared to their body. So what we would do, again, type in the data set, chaining operator, and then instead of select now, we're going to use mutate. So here's the first thing you're going to type in is the name of the new variable. So we're going to say proportion, we'll just say prop for proportion brain weight. And then we're going to type equals. And now what do we need to find this proportion? We need brain weight, and we divide that by body weight. Now we can notice that some of these brain weights are NA, so they're either so small that they're not included, or they just don't know the correct answer within this data set. That's fine. We'll type in brain weight anyways, and then the division symbol, and body weight. And now if we run this, we have a new data set. We can see that there's an additional column, which is indicated by the 12 there. We had 11 before. And we're going to have to scroll to the end to see that because it automatically puts it at the end of the data set. So now we have a proportion brain weight. So we can see that this first proportion for whatever animal this is 0.03. So that's one way to use mutate, is to create a new numerical variable. But let's say we don't want to make a numerical variable. Let's say we want to make a categorical variable. So I had this one already in here. I'm going to uncomment that. So what am I doing here? I have the data set, chaining operator, and mutate. And now we have an indicator variable saying whether or not brain weight is NA. I know we looked before and we saw that some of these brain weights are considered NAs. So I have a new variable called brain NA, and it's just going to say true if brain weight is NA, and it's going to say false if it's not. So let's see what that looks like. So again, we have an additional column. We'll scroll to the end and look at that. So here, now we see that anytime brain weight is NA, we have a true value there. So that might be useful for anytime you're looking at comparing animals that have an NA brain weight versus animals that don't have an NA brain weight. There might be some kind of difference that you're interested in looking at in a data set like this. Excuse me. So that's one way you can use mutate, and you can do this with all different kinds of operations. You can do sums, you can do division, multiplication. You can check for specific strings in a string variable. You can do all kinds of things. Those are a little bit more advanced, but that's the basics of mutate. All right, so let's go on to the next one. That's going to be filter. So filter does exactly what you think it sounds like. It filters the data set based on rows. So unlike select, where you're filtering it based on columns, here you're filtering it based on rows. So let's first look at a categorical example of that rather than a numerical. So we're going to say msleep, which is the data set, of course, chaining operator, and then filter. So what is a categorical example that we can look at? Well, I think it would be a good idea maybe to look at carnivore, or omnivores, or herbivores. So there's 3 different categories here for vor. And let's say we want to look at only animals that are omnivores and herbivores. So we're going to filter that data set. I'm going to say vor. And just to make it easier, I'm going to actually make a list here. So we'll say vor list equals, and we want to look at omnivores and herbivores. So we're going to make a list. We have omni, and then we have herbi. Let me make sure that's how it's spelled. Herbi, omni. Okay. So now we have our list of the categorical variables that we're interested in for vor. So we're going to say filter vor %, in %. So that's going to be looking for the vor column, and it's going to be looking in the list of vor list. So we'll type in vor list. Let's run that. All right, so now we see that we still have 11 columns, just like before, but instead of 83 observations, we have 52. And we can go to the vor column and make sure that everything's right. So we can see that all of these animals only have omni or herbi in their vor column. We can go through a few pages and look at that for sure. I don't see any carnivores, so that's good. So another example of way we could do this is with a numerical variable. So I'm going to delete this. And again, for a categorical variable like this, you could say vor not in vor list, and then it would only return carnivores. But I can leave that for you as an example you can do on your own. I'm going to delete this. We can go into the numerical variables. So let's look at a numerical variable that we would like to sort by. So we can see here that we have a lot of different animals with over 12 hours of sleep total. Let's say we only want to know what animals have sleep total less than 12. So we can do that exactly the same way as we did the categorical variable. So msleep, chaining operator, filter, and we want to have sleep total less than 12. So you read that just like it sounds, and it works just the same way. So in the msleep dataset, we're going to filter by sleep total less than 12. So we're going to run that, and we can see again that instead of 83 observations, we have 52. And let's scroll over to the sleep total column, and we see that all of these sleep totals are less than 12. You can scroll through a couple pages and see the same exact thing. So you can do this just like this. And let's say we want to do a little bit more of an advanced filter. So we have sleep total less than 12, but let's say we also want to only look at animals that have a sleep total greater than 4 as well. So less than 12 and greater than 4. So what we can do is put the and symbol, sleep total greater than 4. Now if we run this, it's going to be even less than 52. Now there's 42. And again, we can scroll over to the sleep total column, and we see that all of these are less than 12, but greater than 4. So it's another way you can use the filter function within Tidyverse. All right, so now we're getting into group by. And instead of explaining group by itself, it doesn't really make much sense. If I were to type msleep, and we wanted to group by a column, so it's going to grab all of the columns that match your grouping statement and put them together, and you would normally summarize or mutate based on those groupings. However, if you just group by, it doesn't really have any operation to do on that, so it can't do anything for you. It's just going to return the data set by itself. So let's say we wanted to group by vor, and we just typed that in. This will not throw an error, but it will just return the data set as is. You can see 83 different rows and 11 columns. There's 5 groups for vor, but that doesn't really help us because it didn't filter down, or it didn't group the rows in a meaningful way. So instead what we can do is use something called summarize. And this will make a little bit more sense. So if we group by vor and we summarize, so summarize is something you're going to be using with grouping by a lot. And what this is going to do is it's going to group by the different categories within vor. And let's say we want to look at the average sleep time total. So we'll say average sleep total. And that's going to be in the name of the new column within our grouped data set or aggregated data set. And so to find that, we're going to say mean, the mean function, and we'll look at sleep total. And just in case there's any NA values, I don't want that to throw any weird things. I'm going to say NARM equals true. That's just something I put into those just so nothing weird happens in case there is an NA value. All right, so now we see that we have our data set grouped by vor. So we have carnivore, herbivore, insectivore, which I didn't even know was a thing, and omnivore, and then any case where there's an NA value. And then displayed is the average sleep total. So they take the mean of the sleep total columns for each of those groups, and they find those and they display those there. So again, similar to the last example, you can add in another one. Oh, that comma should go after. So let's say we not only want to look at average sleep total, but we want to look at the average sleep REM. So we can say average sleep REM equals mean sleep REM, comma, na.rm equals true. So if we run that, Now we have the same thing grouped by var. We have average sleep total just as before, and we also have the REM sleep average here as well. So that's grouping by and summarizing. And now we can do another thing with grouping, and that's mutating a variable. So let's say we want to msleep, chaining operator. This time let's group by something else. What can we group by? Look at order. There's a lot more groups, so it's going to be a longer data set, but that's okay. So we're going to group by order. And this time, instead of summarize, let's do mutate. So we want to make a new variable. Let's go similar to before, and we will do proportion. So let's go proportion of REM sleep to sleep total. So how many of the different orders, what is the proportion of their REM sleep to their sleep total? So REM to total. So that's the name of our new variable. And then we can take sleep REM divided by sleep total. All right, if we run that, now we can see we have an extra column now. So instead of summarize, it's going to aggregate the data and put it all down to a smaller data set. But if you use mutate, it's just going to take those groups and add on and tack on an additional column that you're going to be looking at the end. So let's scroll over and see what that looks like. So now we have REM to total proportion. So for each order, which you can scroll back and see those orders. Where is it? Okay, there's order. So we can see that here's an example where there's there's carnivoras, 3 carnivoras in these first 10 rows. So we'll look at row 1 and then these 2 rows down here and compare those. So if we go to REM total, you can see that, oh, okay, so for carnivora, that's NA. I probably should throw in NA equals, well, since there's NA values for one of them, it just throws off everything. So I apologize for that, but either way, we're grouping by order here and showing that proportion. So these proportions will be the same for each of the separate orders. So that's another way that you can use grouping by with mutate. All right, now finally, the last concept that I want to go over is ranging. So let's say we did our group by like we did before. So msleep, group by, var, and then we wanted to look at the average, summarize by the average sleep total equals mean sleep total. And I'll throw in na.rm equals true. So if we run that, it's just like it was before. You can see our different vars and average sleep totals. But you can notice that these sleep totals are not organized very well. So let's say we want to organize those by from highest to lowest average. So it's easier to see that. So we'll add another chain to it, and we will say arrange. You can see that that's in the Dplyr package as well. And we want to say descending because we want it from high to low. And what do we want to do arrange it by? We want to arrange it by average sleeped total. So descending by average sleep total. Now if we run that, you're going to get the same data frame, but it's going to be sorted by highest average sleep total to lowest average sleep total. So that's a nice thing. If you're just looking at a data set, it's going to visually give you that indication that insecti is the highest and herby is the lowest. So you can just see it a lot easier. And that might be useful for plotting in the future. So let me know down in the comments if you do want to see an example of a plotting tutorial in the future. So let me know. And now the nice thing about these is that you can keep chaining these and get more and more complex with some things here. So I'm going to give you one last example, and we can end on that. And then if there's any questions, you can throw them in the chat and I'll answer them. So if you're watching this live, you'll hear those questions. But if you're watching the recording, I'm going to probably cut it off. But here's an example of, let's do something a little bit more complex. So we'll go msleep. And what do we really want to find? So let's say we want to first filter the data set before we do anything. So let's say we want to see only animals that sleep longer than 12 hours, first of all. So let's say filter, sleep total, greater than 12. And okay, so now that we have that, what else do we want to look at? We only want to look at, let's say, carnivores and omnivores. We only want animals who eat meat. So we can actually add that to a filter as well. So we'll just put comma or and. I'll make another list. I'll call it meat eaters. So list, and we'll say omni and carni. So and we want vor in meat eaters. All right, so let's say we just end it right there and we were to run this. You can see now that we have a data set with 12 animals. So they all sleep longer than 12 hours and they're all carnivores or omnivores. So there's only 12 animals out of the 83 that fit those descriptions. Okay, so we don't want to break this up too much more because we're going to be losing more and more information every time we do. We'll add another one. So let's say we want to mutate this. Well, actually, let's group by vor. We'll do that. As you can see, these can get a little bit complex. So group by vor. And what do we want to do with that? We want to mutate these. And we want to add a new variable. What can we do here? So let's say we want to look at the average brain weight. So we're going to do the average brain weight to body weight proportion and compare that to their own proportion. So it's going to group by the omnivores and the carnivores and find the average brain to body proportion and put those. So we'll say average proportion, I'll just put prop, equals mean brain weight divided by, we'll put na.rm equals true, divided by the mean body weight, na.rm equals true. That just skips over the NAs, by the way. It doesn't factor them into the mean. Because if you don't, it just kind of, it can throw some problems like we saw before, where you have an NA for a value that shouldn't be an NA. All right, but now we have average proportion, so it's the mean brain weight divided by the mean body weight. And now we want just the, need that extra parenthesis. But first, actually, before we group by, let's add another variable that's just the brain to body weight proportion just for that particular row, and then we can compare them. So we'll say mutate brain body proportion equals brain weight divided by body weight. All right, so now this allows us to compare that particular row's brain to body weight proportion to the mean for their for vor. So I'll explain that a little bit more when we run this. So that should be good. We can run that. There shouldn't be any problems. All right, so see, we still have 12 rows. We have 2 new columns though. So let's look at those 2 new columns. So here, you can see that this average proportion here is the proportion only for carnivores. And that second one is going to be the proportion for omnivores. So you can see that these two are both omnivores and this one is a carnivore. So you can compare that to their regular brain and body proportion here. So you can see this one has a 0.03 and that is lower than, or actually higher than the average for omnivores. So that's kind of an interesting thing you can do. And as you can see, you can kind of get as complex as you want with these groupers and these functions. So I hope this was helpful to you, and if it was, go ahead and consider subscribing.